Chapter 10, Exercise 13, is asking you to balance a few equations. But what's new about this, that's different from Chapter 6, when you learned how to balance equations in general, is that these are going to be neutralization equations. So let's come to terms with that word. A neutralization reaction is a reaction where an acid combines with a base, and when that happens, they produce a salt and water. They also usually produce heat. Now, you'll be able to recognize an acid because it'll have an H out in front. We've seen that acids are things that can donate H pluses. So you'll recognize those by an H. Bases will be able to be recognized most of the time by OHs in them. Remember the Arrhenius definition of a base from earlier in this chapter. The bases usually have OH minuses in them. And then you will get a salt. Now, a salt in chemistry is a much broader term than the way we use it in life. In daily life, salt is table salt. But table salt is just one type of salt. A salt is a metal and a nonmetal. If you ever combine a metal and a nonmetal, it gives you a salt. So there are hundreds of different types of salts. And in each neutralization reaction, the salt can be different. What's always the same is water. Water, of course, is H2O. So that's a particular reaction type where acids and bases neutralize each other to produce a water and a salt. And that's what's happening here. You can see that in 13a, we have an acid, HCl. That's actually stomach acid. And you know it's an acid because it has that H in front. Then we have a base. And you know MgOH2 is a base because it has that OH there. We have water. So we have water here. And notice it doesn't matter which comes first, the water or the salt. And then we have a salt. Magnesium is a metal, chlorine is a nonmetal, so magnesium chloride, MgCl2, is a salt. So this is classified as a neutralization reaction, and we want to balance it in this problem. Okay, so first I'm just going to write this out so that I have a little more room between everything. So HClAq plus MgOH 2. This S means it's a solid, and that's going to produce H2O. The L here is telling you that you have a liquid, and then MgCl2. And the AQ here is telling you that that is aqueous. It's dissolved in water, as if it were in an aquarium, or if it were aquatic. Now, the trick with balancing neutralization equations is to balance the oxygens and the hydrogens last. Usually, if you balance the other elements first, the oxygens and the hydrogens will sort of fall into place. So let's start with chlorine. How many chlorines are there on the left? Just one. There's no number written at the bottom right of chlorine, so there's an implied 1. How many chlorines are there on the right? There are 2, because there's a 2 at the bottom right of chlorine in that compound. So we need to multiply the smaller number by something to get the larger number. So what do we need to multiply this 1 by to get 2? 2. 1 times 2 will give you 2. And so now the chlorines are balanced. We have 2 on the left. Remember to distribute this to each of the elements. So 2 chlorines on the left, and 2 chlorines on the right, as we saw. Okay, so the chlorines are balanced. Next, let's look at magnesium. That's the only other thing that is not oxygen or hydrogen. How many magnesiums are on the left? Look at the bottom right of magnesium. No number is written there. So that means you only have 1 magnesium. This 2 only applies to the stuff in this parenthesis, not to the magnesium. So we have 1 magnesium on the left. How many magnesiums do we have on the right? Look at the bottom right of the magnesium. Nothing is written there, just an implied 1. So we have 1 on the right. Okay, so now the magnesiums are balanced. Okay, now that we've balanced everything that's not oxygen or hydrogen, we can start to balance the oxygens and hydrogens. Now, I would encourage you to balance the oxygens first, because notice hydrogen is on more than one thing on this left side. So it's going to be harder to take that into account, to keep track of that, than it would be to track the oxygen, which is only on one thing on each side. So let's try to balance the oxygens. How many oxygens do we have on the left? Only this compound has oxygen in it, and inside the parentheses you have only one oxygen, but you want to distribute the two outside of the parentheses to each of the elements inside. So here you actually have 2 oxygens. Because you have 2 of everything inside the parentheses, that's what this 2 is talking about, and oxygen is inside the parentheses. So 2 oxygens on the left. How many oxygens do we have on the right? Oxygen is only an H2O on the right. And if you look at the bottom right of the oxygen, nothing is written there, so there's only an implied 1. Okay, so we have 2 oxygens on the left, 1 on the right. What do we need to multiply the smaller number by to get the larger? What do we need to multiply 1 by to get 2? 2. 1 times 2 will be 2. And so now, you would distribute this 2 to each of the elements. It distributes to the oxygen, and you'd have 2 total oxygens. So the oxygens are balanced. Now usually, if you've balanced everything that's not hydrogen and oxygen, and you've balanced the oxygen, the equation should be balanced. Let's go back through and check. So first, chlorine. We have 2 chlorines on the left. Remember to distribute any number in front. 2 chlorines on the left. How about on the right? 2 chlorines on the right. So, the chlorines are balanced. Next, magnesium. We have 1 magnesium on the left. Remember to look at the bottom right of the magnesium. Nothing's written there, so that's an implied 1. And we have 1 magnesium on the right. Same principle. Nothing is written at the bottom right of the magnesium, so it's an implied 1. So the magnesiums are balanced. Okay, next. Hydrogen. Why not? We haven't even looked at it yet. Now hydrogen is in 2 different molecules on the left. Let's look at each one separately. In this first molecule, remember to distribute the 2 to each element. There are 2 hydrogens. In the second compound, inside the parenthesis, there's just 1 hydrogen, but we have 2 of everything inside the parenthesis. So we're distributing that 2. In total, that'll be 2 hydrogens from the second compound. So that total, we have 4 hydrogens on the left. Hydrogen is only in water on the right. Remember to distribute the 2. There's a 2 already at the bottom. When you distribute, it'll be 2 times 2. That means 4 total hydrogens on the right. And the hydrogens are balanced. 4 on the left, 4 on the right. Okay. Next, oxygen. Oxygen is only in the magnesium hydroxide on the left. There's 1 inside the parentheses, but we have 2 of everything inside the parentheses. So you distribute. 2 times 1 is 2 oxygens on the left. On the right, oxygen is only in water. Remember to distribute any number in front. We only have 1 oxygen. Once you distribute the 2, it'll be 2 times 1, 2 oxygens on the left. So, number of oxygens on each side is equal. The number of every element on each side is the same, and so this equation is balanced. So this would be the balanced equation for this neutralization reaction. This is actually a reaction that you will probably run into as a nurse. HCl is stomach acid. MgOH2 is an antacid. That's something that you would give to elderly people or younger people who are suffering from acid reflux, where the acid in your stomach shoots up into your esophagus. That acid burns your esophagus and creates what's called heartburn. You can give the patient a purple pill, it's called, of magnesium hydroxide, and that'll neutralize it, so it'll just be water and a salt inside of their esophagus, and they won't get that same damage that comes from heartburn. Okay, next, let's try to balance the second one. Remember our strategy. Balance everything that is not oxygen or hydrogen first. Now this one's a little tricky because it has a polyatomic ion in it, but it's one of the 3 that you would want to memorize. PO4. PO4 is the polyatomic ion phosphate. And so because that appears on both sides of this equation, we're going to treat that as just one blob. PO4 as one thing. We're not going to look at it separately as phosphorus and oxygen, but instead as one thing, PO4. Okay. So first, let's balance the PO4s. How many PO4s are on the left? Look at the bottom right. Notice I'm not including the 4. That's part of that blob. So at the bottom right of that, nothing is written. That means that we only have an implied 1. How about on the right of the arrow? Look at the bottom right. Notice I'm not including the 4. The 4 is part of that big polyatomic ion. All sticks together and acts as one thing. Outside of the blob, no number is written, so there's just an implied 1, and the number of phosphates, PO4s, are balanced. Okay, let's go on to the other thing that is not oxygen or hydrogen, and here that's lithium. How many lithiums are on the left? Look at the bottom left. There's only 1. How many lithiums are on the right of the arrow? Look at the bottom right. There are 3. So what do we need to multiply the smaller number, 1, by to get 3? 3. So that would bring the number of lithiums we have to 3, and now the lithiums are balanced. Okay, let me take a second to rewrite this equation so that we have a little more room. So we have H3PO4. The AQ means it's dissolved in water, it's aqueous. Then now we have 3 LiOH, that's lithium hydroxide. The AQ here means it's in water, dissolved in water. Then we have H2O, so that's a liquid, plus Li3PO4, and that's dissolved in water. Another thing to note is that this is a neutralization reaction. We have an acid, you can tell by the H's in front. We have a base, you can tell by the OH minuses. We have water, and we have a metal and a non-metal. That's a salt. So an acid plus a base giving water and a salt is a neutralization reaction. Okay, back to balancing. So we balanced the phosphates, those PO4s, which we're treating as just one thing. We balanced the lithiums. We saw that there are 3 on both sides. So now we can go on to the hydrogens and the oxygens. I encourage you to balance the oxygens first, because hydrogen is on 2 places on the same side. So it's not clear where to put the number to balance the hydrogen, whereas oxygen is only in one place, so it's clearer where to put that number, if we do need to add a number. Okay, how many oxygens are on the left side? Notice, I'm not going to include the oxygens and phosphate, because that is sticking together with the phosphorus to all act as one thing. We've already balanced that big thing when we balanced phosphate. So I'm going to ignore those oxygens now. Only the oxygens outside of phosphate are the ones that I'm going to look at. So outside of phosphate, oxygen is only in this other compound. How many oxygens do we have there? Remember to distribute the 3. The 3 goes to the lithium, to the oxygen, and to the hydrogen. That means that we have 3 times however many oxygens are in the compound. And there's only 1 if you look at the bottom right. So that's a total of 3 oxygens on the left. How many oxygens are on the right? And again, I'm ignoring the oxygens and the phosphate because we've already taken care of those. So I'm only looking at water now. Look at the bottom right of the oxygen. Nothing is written, so that's an implied 1. So what do I need to multiply the smaller number 1 by to get the larger number 3? 1 times 3 is 3. So I would need to multiply that by 3. And that would give me a balanced number of oxygens. Okay, so now the oxygens are balanced. And like we said, usually if you've balanced everything that's not oxygen or hydrogen and the oxygen, the whole equation is balanced. But let's check. So let's start with the hydrogens. How many hydrogens do we have on the left? Hydrogen is in both of these compounds. Let's think about them one at a time. On the left, in the left compound, we have 3 hydrogens. On the right, remember to distribute the 3. We have 1 hydrogen in the compound, but 3 of that compound, so a total of 3. That means that the total number of hydrogens on the left is 3 plus 3, or 6. How about on the right? Hydrogen is only in water. Remember to distribute the 3 to each of the elements. We start with 2 hydrogens in each compound, but 3 compounds, so 3 times 2 is 6, and the hydrogens are balanced. Okay. So, hydrogen is balanced. Now let's think about the other things, just to check. How about phosphates? One phosphate on the left. Notice outside of that highlighted area, there's no number, so it's an implied 1. One phosphate on the right, same thing. So just 1. So the phosphates are balanced. Okay. How about lithiums? We have 3 lithiums on the left. We have 3 lithiums on the right. And so those are balanced. Last but not least, oxygen. How many oxygens do we have on the left? Notice I'm going to ignore the oxygens in phosphate because we've already thought of those. We've already taken those into account. So I'm only looking at the other compound. Remember to distribute this 3 in front to each of the elements in the compound. At the bottom right of oxygen is 1, so I'm going to multiply that 3 by that 1. That gives me 3 oxygens on the left. How many oxygens do I have on the right? I'm only looking at the water because I've already looked at and balanced the phosphate. So here, remember to distribute the 3. There's a 1 at the bottom right of the oxygen, times 3 is total of 3. So the oxygens are balanced. So every element is balanced, this whole equation is balanced, and this is the neutralization reaction that happens when you react phosphoric acid, that's in, for example, Coca-Cola, with lithium hydroxide to give you water and a salt. So these 2 questions give you a sense of the process for balancing neutralization equations. First, balance the elements that are not oxygen or hydrogen. Then balance oxygen, and then go back and check to make sure everything is balanced.